So again, could be a typical polynomial in factor form. Now expanded. Okay, if it's in this form, just quickly, it's easy to graph. You know, you have a 0 at x equals 2, a 0 at x equals 4, and a 0 at x equals -3. You know that the y-intercept occurs when x equals 0. That's going to be at x equals 24. Or y equals 24. Sorry. So we've got these 4 points on the graph. You test the long run behavior as x goes to infinity. All these numbers are going to be positive. If x is a big positive number, all 3 of these factors will be big positive numbers. And when you multiply them together, you get a huge positive number, meaning as x goes this way, y goes this way. So you, ouch. Stop that. Okay, you put an arrow here to indicate that after you get through this point, you're going to take off. Okay, then if x is a big negative number, then each one of these is a big negative number. Take a big negative number and subtract 2 from it, you still got a big negative number, right? If you're in debt $50,000 and subtract 2 from that, you're still in debt about $50,000, right? Okay, negative number, add 2 or subtract 2, 3, or 4, still going to be about the same. So you got a big negative number. Each of these is a big negative number. If you multiply 3 big numbers, you're going to get a really huge number. And if the 3 numbers are all negative, you're going to get a negative because of the way signs work. Negative times a negative is positive, then times a negative gives you negative. And I'm thinking some people are having trouble with that idea. So you really have to understand rules for multiplying sign numbers. I think you do. But somehow, when it's put into this context, maybe get confusing. So, okay, so anyhow, you're going to get this. I haven't written all the details of that out, but you should write all the details out. And I wrote them out last. Okay, write things out the way I write things out. You'll reinforce it, you'll retain it, and you won't get to a test where you can't do the things you did well a month ago. Okay, or you're much less likely to get to the test and not be able to do the things well that you did just fine a month ago. Okay. And then you can simply connect these. I kind of missed that one, you understand? Okay. So when a polynomial is factored, it's pretty easy to graph it. Now, if you got multiplicities, then, well, we talked about that last time. We'll talk about it a little bit more this time, okay? But right now, I want to talk about what you do if you have a polynomial. Here's P of x. Now, I can multiply x plus 3 by x minus 4. I'm going to get x squared minus x minus 12. Use distributive law to do that. And I'll use the distributive law in the next step. I say that equals then x times x squared minus x minus 12 minus 2 times x squared minus x minus 12. In other words, x minus 2 times this means x times this, and then minus 2 times this. There it is. Write it out. That's your distributive law. And you then multiply it out at x cubed minus x squared minus 12x here. Every term multiplied by x. And then you're going to get minus 2x squared plus 2x plus 24. And then you put all that together, you've got x cubed. Then the minus x squared and the minus 2x squared gives you minus 3x squared. The minus 12x and the plus 2x gives you minus 10x. And now you've got before. Now let's pretend given p of x equals x cubed minus 3x squared minus 10x plus 24. How do you graph it if you don't know how it's factored? Because can you factor that? Can you figure that this is equal to this? You didn't already know it? Really not. Okay. In general, there's no easy way to do that. Well, what you can do is given this and given that p of 2 equals 0, and it's not hard to figure out that p of 2 is 0 for this function. You just try a few small numbers. Okay. If you plug in 1, you get 1 minus 3 minus 10 plus 24. That doesn't equal 0. If you plug in 2, though, you get 8. And you get minus 24. And then you get minus 20. No, sorry. You get 8 minus 12 minus 20 plus 24. I make a mistake down here because it doesn't seem to work out. Check my arithmetic. X squared minus x minus 12. It's going to give me an x cubed. It's going to give me minus 2x squared. And the minus x squared is minus 3x squared. It's going to give me 2x minus 12x minus 10. That's going to give me 24. 8. Something a little messed up there. Let's see this stuff. So either I can't do this arithmetic or something else. Never mind, it's right. Okay. Sometimes my head wasn't calculating that right. If we know that 2 is a 0, this thing, then we know x minus 2 is going to be a factor, don't we? We might not know what the other two factors are, but we know x minus 2 is going to be a factor, because if x minus 2 wasn't a factor, we wouldn't get a 0 here. Okay? That's why we know that if p of 2 is 0, this thing is divisible by x minus 2. Hope the math is going to tell you the same thing in slightly different words. So we divide p of x by x minus 2 and see what we get. What's going to turn out that what we get is just a quadratic expression. And that quadratic expression is something we're going to be able to factor. Or we can at least plug into the quadratic formula and find its zeros. As it. Okay. So we're going to do that. I'm going to use long division. Now there's a reason long division works, but I'm not going to belabor you with it right now. I will probably talk a little bit about it later. But we write a thing like this: x minus 2 divided into x cubed minus 3x squared minus 10x plus 24. Now, we want to put something here that when we multiply by x, we get x cubed. What do you multiply by x to get x cubed? How many see what we would multiply by x to get x cubed? Let me know if you. Yeah. So let's just talk about it. Everybody's heard it, but we do want to get it into the recording. Now, I think that this function has zeros at -3, 2, and 4, and has a y-intercept at 24. And behavior or long run behavior, as x goes to infinity, the thing goes to infinity really fast. As x goes to negative infinity, goes to negative infinity really fast. So there's a graph. Okay. So if it's in this form, it's easy to graph. Now, if I multiply this thing out, I get this. So if you didn't know this, and all you have is this, how would you factor it to get the graph? Okay. Now, if it's trinomial, you probably learn to factor those. That's one thing that people do come out of K through 12 knowing how to do pretty well, if they've had the algebra one. Well, okay, let's say we're given this, and we're also given that P of 2 equals 0. Now, you can do some trial and error with small numbers like 1, 2, 3, or -1, -2, -3. See if one of them gives you 0 here. If you can find one that makes this 0, then you don't have to give it. But let's just say you're given that P of 2 equals 0. And you can plug 2 in here, you're going to get 8, you're going to get -12, you're going to get -20, you're going to get 24. -12 minus 20 is -32, 8, 24 is 32. You get C. Okay. So we know then that this is divisible without remainder by x minus 2. How do we know that? We know that in order to get a 0 at x equals 2, a polynomial has to have a factor x minus 2. If it has a factor x minus 2, that means x minus 2 would divide this. And if you divide this by x minus 2, you get x plus 3 times x minus 4. Okay? Well, we're going to divide this polynomial by x minus 2 and see what we get. Okay? So we write x minus 2 into this, and then we figure out what to put up here. And I think we did some of this. I'm not sure. Okay. Again, I asked, what would you put here? If you multiply by x, you're going to get x cubed. Okay. People couldn't answer that or didn't want to. So we digressed, said, okay, what's x cubed times x to the fourth? X to the what? About half the class held up 7 fingers. Okay. And I think most of the rest kind of knew it. Just didn't want to commit themselves. Okay. Why is x to the third times x to the fourth equal to this? Because x to the third means this, x to the fourth means this. X to the third has 3 x's multiplied by each other, multiplied together, and x to the fourth has 4 x's multiplied together. If you got 3 x's multiplied together times 4 x's multiplied together, that means you got 7 x's multiplied together, which means you got x to the seventh. Okay. Now then we look at x to the fifth times x to the a equals x to the ninth. What does a have to do? Well, you see that you're going to add the number of x's here to the number of x's here to get the number of x's here, and that's going to be your exponent. That means you're going to add this number and this number to get this number. Because this number is how many x's you got here, this number is how many. So you know now that you're going to add exponents when you multiply the two powers of x. So you're going to add 5 and something to get 9. What do you add to 5 to get 9? Well, everybody knows it's 4. Most people held up 4 fingers pretty good. Okay. Similarly, now x to the what power times x equals x to the fourth. Well, it's all out of this, and that's right. Because x is just x to the 1. So if you got 3 x's and then another x, you're going to have 4 of them. Okay. So now what do you multiply by x to get x cubed? You can answer the question. It's going to be x squared. Okay, so x squared times x gives you x cubed. And x squared times -2 gives you -2x squared. Okay, because whatever you get up here, when it's multiplied by this, has to give you this. Well, if I have x squared up here, then I've already got my x cubed, right? Because when I multiply x squared by my x, it's going to give me my x cubed. So I've got my x cubed. If I've got x squared here, it's going to also be multiplied by the -2, so it's going to have a -2x squared. Now I want to subtract the x cubed and the -2x squared from what I've got up here to see what I still need. And now whether you totally understand that or not, the algorithm is I write this down and I subtract this stuff. Subtract. It even helps if you got a little colored pen. X cubed is positive, but I'm subtracting, so I'm going to put a little negative there to remind me I'm going to do this minus this. And I've got a -2x squared that's going to be subtracted. That's the same as adding 2x squared, so I put a little plus there. So I do -3x squared plus 2x squared to give myself -x squared. Okay. Now I'm still going to need then -x squared. And I'm going to need -10x. I'm going to need plus 24. How am I going to get it? Well, how do I get a -x squared? I put a -x up here. -x times x gives me my -x squared, right? And then -x times -2 also gives me 2x. So mechanics is I just multiply this by this, write it down here. And the 10x wasn't originally there. 10x is up here. I don't want to have to look all the way up here. I write it down here. All right. Then I put my little auxiliary signs. Since this is negative and I'm subtracting it, I'm really going to add it. So -x squared plus x squared gives me 0. Don't have to write anything down. And then -10x minus 2x is -12x. And now what do I need to get -12x? Well, what would I multiply by x to get -12x? It would be -12. -12 times x gives me the -12x. -12 times -2 gives me a plus 24. And then if I continue to follow the algorithm, I gotta subtract this from this, so put my auxiliary signs up here. Subtract, I find there's no remainder. My conclusion is then that the original form of the polynomial, the x squared minus 3x squared minus 10x plus 24, which we see here, is equal to this times this. So there it is. This is equal to x minus 2 times x squared minus x minus 12. Now, we factor x squared minus x minus 12. It's easy to factor. We get x minus 4 times x plus 3, and now we've got it. Okay. If you can't factor x minus 4 times or x squared minus x minus 12, even though it's easy to factor, you could use a quadratic formula. You could set this equal to 0 and see what makes it 0. You would find that x equals 4, x equals negative 3, and that would give you your x minus 4 and your x plus 3. In any case, then, if you're given this without knowing any of that, you would now have that, and you can make that graph very easily. Everybody okay with that? Get the idea? Again, there are little twists and turns that can occur in the process, but if you understand that much, then I believe that by working through open math and paying close attention, and please let me keep emphasizing, you're going to hear it more than you want to probably, but pay attention to the details. Focus on the details. Make sure you have, okay? Because you can easily work through problem set by getting in the habit of doing certain things at certain times without really thinking about why you're doing it. Okay? Now, one thing I can do, and I kind of wish I had, and I think in the future I will, including the rest of this course, I'm going to give you a quiz at the beginning of class. There'll be 2 things in the quiz, and one of them is a review. Something that I know you're going to want to be reminded of. Okay? I could have been doing that all semester. You know, if I had to do over again, what they, you know, we'd have to sacrifice something else for the time to do that, but I think it would be to your benefit. So I think in the future, I'll try to make sure I do that. Again, now, how do we graph a factored polynomial? We find the intercepts, we find the long run behavior, and then we take account of multiplicity. Okay, so this is it. Accurate if necessary. Possible because most of the factors you encounter in the real world, you can't factor. Okay. But there's something you can do. It's pretty easy. We're not going to do it this course. Okay. So what you're learning here will work with just one little additional step, which is basically you use a machine to graph it to figure out what the intercepts are. Stuff. Okay, so to graph a polynomial, you factor it if necessary and if possible. Find the intercept, that's the x-intercepts and the y-intercepts. Okay. Determine long run behavior. And consider multiplicity. Okay. See how much of that you can do and how much time we've got in about 4 or 5 minutes. That means x-intercepts and y-intercepts. I'm just giving you the overall. You know, but you find the x and the y-intercepts because you always do that. Okay. Well, let's say y-intercept x equals 0. Now you write this down every time you do it. Okay. That's one of the habits you get into so that you remember that the y-intercept happens when x equals 0 and you reinforce that idea. People tend to gloss over steps and steps in writing out things that you really need to remember that people often fail to remember. So y equals 0 minus 4 squared times 3 minus 0 cubed equals what? 4 squared is 16, 3 cubed is 27. And everybody knows that 16 times 27 is 300. And, well, I'm 16 times 3 is 480 minus 48, 432. Right? Everybody get 432. Okay. The brain has worked too fast this morning. Let's be around. Okay. X-intercepts. Y equals 0. So y equals p of x, which is x minus 4 squared, times 3 minus 6x cubed equals 0. This means x minus 4 is 0, or 3 minus 6x equals 0. Now, this is as I've said that you need to do. Okay. You need to write these things out so that you're working within a structure that makes sense of everything. And you get x equals 4. And of course, you can solve that. That's a very simple linear equation. Subtract 3 from both sides and divide by -6. And you get, I've got 3 dots there. You get x equals half. So now I know quite a bit. Know that when x equals 4, it's proved the x-axis, and when x equals 1/2. graph goes through the x-axis. I also know it goes through the y-axis with x equals 432. Y is 432, sorry. Well, my picture, you always get a picture that looks like this. You're gonna have one y-intercept, because you always have a y-intercept. And then depending on how many factors you have, you'll have that many zeros. Now you note the multiplicity of the zeros. Well, that's the last thing, so I'll come back to that. Long run, yes, as x goes to negative infinity, just in interest of time. And usually that one's a little more. As x goes to negative infinity, x minus 4 goes to negative infinity. X minus 4 squared goes to plus infinity. What's this mean? Means if x is a really big negative number, x minus 4 is a really big negative number. Well, we talked about that already today. And if I square a really big negative number, I get a positive number, don't I? And since it's a really big number that I'm squaring, I get a really huge number, okay? So x minus 4 squared goes to plus infinity. Well, that's not all, because of course now we have, and then it's 3 minus 6x goes to go to negative infinity or positive infinity. Tell me. Positive infinity, negative infinity. Which? Somebody had a digestive incident there. I can't identify it by half. Oh, that wasn't really digestive. Okay. At least I hope that wasn't digestive. It's okay. Okay. So again, that go to positive infinity or negative infinity? Show me again. Okay. Now, x is a really big negative number, right? So if x is a big negative number, what's negative 6x? It's going to be even bigger, but it's going to be positive because you're multiplying by negative 6. Negative 6 times a big negative number is going to be positive. You have to understand that. Okay? So be sure you test it. See, every example we've done so far, each of these has automatically been negative as x goes to negative infinity. That's what I mean about getting in the habit of something. Okay? You have a negative multiple of x here. So if x is a big negative number, this is going to give you a big positive number. So 3 minus 6x cubed goes plus infinity. So the product, x minus 4 squared times 3 minus 6x cubed, is a product of two things that both go to plus infinity. goes plus infinity. So we have this behavior over here. Now, on the right, I'm not going to write it all out, but you should. In every detail, make sure every detail is there and make sure it's right. Okay. Once you lock it in, it's going to tend to stay locked in, especially if you write things out in detail. If I look at it, if X is a big positive number, this is a big positive number, right? So that's going to be positive. If X is a big positive number, you have negative 6X, which is going to be a big negative number. And adding 3 to a big negative number ain't going to change the fact that it's a big negative number. Now, when you cube a big negative number, you get a humongous negative number. Because you're cubing a negative, it means negative times negative gives you positive, then times a negative gives you negative. You got to think that through. You can't just guess at it. Okay? So that write this much out. This product goes to negative infinity. The x minus 4 squared goes to infinity. But the 3 minus 6x cubed goes to negative infinity. So you got a huge positive number multiplied by a huge negative number, which gives you a really, really big negative number. That means the graph is going to go down here. Now, last we consider multiplicities. I talked about this last time. The multiplicity that you get from this is 3. Now, this gives you your x equals 1/2, right? So as I labeled it before, this is from your 6x cubed factor. Okay. This it is 3. And I'll write the word cubic. Because the graph, as it goes through this point, is going to behave like a cubic graph. Third power, an x cubed graph. And you got to know what that looks like. Okay. And then here, at x equals 4, this 0 comes from x minus 4 squared. Quadratic there. So now we see that the graph comes down like so. Flattens out just for the instant when it goes through the x-axis, comes back down, turns around and comes up here, acts like a parabola here, acts like a cubing function here, and then goes on down again. Okay. When you do these, label them. Write it out on your paper. I want to see it when you submit your work. I'm not going to penalize you if I don't, but I'm going to worry about you a lot. So I got enough things to worry about. Don't make me worry. Okay. Thought I had a worry yesterday. I thought I was losing 10,000 gallons of water a day. Well, everybody I talked to said when I read the meter, the last digit is the number of gallons. No, there's a decimal coming in there. I thought I was using 100 times as much water as I'm actually using. Now, there's plausible reason for that because somehow my water use in the last couple of months has been like triple what it usually is this time of year. So I knew something was going on. I've got testing to do. So anyhow, again, I was a little worried about that. I was afraid the house was gonna float away. Uh, so don't make me worry about whether you're writing these things out completely, okay? Focus, learn to focus on the details and write them out so you'll have them when you need them on the table.